Good afternoon all, it's Postbag. Right, let's start with not this one. Let's start with this one, which I've already opened, and you can probably tell that this is a BMS. And this BMS looks very much like the Dali, or Daily as I call it, because I know a couple of people called Daily, but there it is. Dali, no, this one is an M-God, but I think it's by essentially the same manufacturer. So you get the BMS, this one is a 20 amp charge current, 40 amp discharge current, and you also get the 9-way connector cable, because this is for an 8-cell LiFePO4 lithium iron phosphate. Yeah, here we are. So I'm doing a translate using the Translate app. 8 series 24 volt battery protection, discharge current 40 amps, charge current 20 amps, lithium iron phosphate. Wiring method is the same. I can't read this very well, and it keeps coming and going. But anyway, I think we get the gist. It's definitely lithium iron phosphate. So let's take this out to the shed and compare it with the Dali BMS that I've got currently connected to my bicycle battery. Well, there's a fair old size difference between these two. This one is a 20 amp discharge, 10 amp charge, and the new one, the M-God, is a 40 amp discharge, 20 amp charge. So how's this system been? Well, it's been fine and it works periodically, but there's been very little sun recently. We're very close to the winter apocalypse. No, not that, the winter solstice, but it amounts to the same thing. So it does fire up every few days and do a 1-hour discharge, and because there's very little sunlight, it pretty much only runs for an hour. There's the ant miner there, and so it generates about a penny. Winter's not much fun for solar crypto mining. Quite apart from the fact that it's very cold out here, 2 degrees Celsius. But the battery is charging. It's getting 180 milliamps. Let's have a look at the sky. Yeah, I mean, it's like this pretty much every day. Just nothing. Nothing, well, lots in terms of moisture in the air, but can't see the sun.
Started recording!
So this item on E of the Bay is this. Now they showed us a purple one, which would have been quite nice to differentiate it from the smaller one, but I got a red one. So I chose the 40 amp discharge, 20 amp charge, and I bought this one from China because it was half the price. The UK seller wanted 40 quid for this one. So £19.94, free shipping, and this one came from Easy Shop 8. I'll put a link in the description below. So that's the new BMS. Now that's going to be wired up. I'll put connectors on here such that I'm going to use it with the new battery, the 32650 array of cells, and there are 32 of them. So I'll do the wiring of that in due course. On to the next. And so next up we have this, and it is a little module, and this has been very kindly supplied by icstation.com. So let's take a look at this. It is another unit. Oh, it's stuck in the bag. Yeah, this is another unit with a little display. It's totally stuck in this bag. I can't get it out because these pins are stuck through the plastic. With a big 30 amp relay and a little display under microcontroller. It's another one of these voltage controlled switching devices. Now this one is a charge controller, and it's only a charge controller. Now I've got currently my solar panel connected directly across the lithium iron phosphate battery because there's quite a good voltage match between them. But I do anticipate an issue come the longer days and the brighter, more sunny days, where the battery is being charged quite aggressively The Antminer comes on by virtue of the discharge controller, the one with the LCD display, but it doesn't actually wind itself up in time and turn on its mining and hashing boards before the high current from the solar panel takes the voltage of the battery so high that the BMS disconnects. And I don't really want the BMS to disconnect. I don't really want the BMS to do anything. So what I want is a situation where the discharge controller triggers at, say, well, it's currently set to 29 volts. And this could be set to, say, 29.5 volts. And when this gets to 29.5 volts, it actually disconnects the solar panel from the battery, only briefly, because as soon as the Antminer starts pulling a significant current, the battery voltage is going to fall back, and this will have a fairly small hysteresis, reattach the solar panel, because of course when the Antminer is mining, you want the solar panel to be contributing towards the current going to the miner, because otherwise it would be wasted. So I do feel that I may need a charge controller, and this is a very simple, primitive charge controller. It doesn't do PWM or MPPT or anything fancy like that. It will just simply disconnect the solar panel if the voltage of the battery looks like it's going to get anywhere near the cutoff of the BMS, because I don't want the BMS to cut off. So that's what I want this for. Let's take a look at this item on icstation.com's website. Here it is on icstation.com, and we've got a discounted price, $8.35, and that's for a remaining 1 day, 2 hours and 11 minutes. So there you go. So this is the XHM604 charge control module. DC 6 to 60 volts is your allowed battery voltage. It does actually say here max 80 volts. Battery protection board controller for lithium or lead acid battery. So I'm going to use it for lithium iron phosphate, and I'm going to use it to disconnect a solar panel, which is my charging apparatus, to disconnect that just briefly if we get anywhere close to tripping the BMS. And we'll have to first test the BMS to see what voltage that disconnects at. So here's some stuff on it. 6 to 60 volts, display precision 0.1 volt, control precision 0.1 volt, tolerances, size, and all that stuff. And again, on this thing, you'll set up an upper voltage and a lower voltage. And on this one, if you go above the upper voltage, it will cut out, the relay will disconnect, and then when you fall back down below the lower voltage, the relay will cut back in, and it only has that one mode, so it doesn't have a discharge mode. So this is typically used to charge a battery using typically a mains battery charger, the DC output of which can go into the input connections, and the battery sits on the battery connections. All the information you need to connect this thing up, and there's even a video here by 12 volt vids. So big thanks to icstation.com for sending me this. I'm hoping actually that unlike some of my other modules where the inductor burnt out, this one, because it's got quite a big chunky inductor, there's not much chance of that happening. So this should be a good addition to the Shed solar power system. Future video, of course, I will test this on the bench, hook it up to the solar crypto accumulation machine, set it up, set the upper and lower voltage thresholds, and do all that good stuff, but that will be in a future video. Okay, moving on. So next up, these two things. Let's unwrap this one. Ooh, nice thick polythene bag on this one. Actually, it's not a bag, it's just some polythene. So this is a solid state relay, SSR 40, and the DD, double D, that actually means DC on the control side and DC on the output side. So this is a 3 to 32 volts, what is in effect the coil. Of course it isn't, it's electronic, but anywhere from 3 to 32 volts on the input, and this will switch on. and you can put up to well 5 to 60 volts on the output. Now I don't know, is this, oh, it does have a minus and a plus on there, but could it switch bidirectionally? I'm not sure. Of course the AC ones do, and they're marked DA, so it's DC on the coil side. It's not a coil obviously, and AC on the output side, but this is a DD. This is DC switching on the output side. Now of course the advantage of this over a relay is that you don't get well, there are a couple of advantages. You don't get the flyback, the back EMF, when you disconnect your control voltage. Also, of course, it has a much lower holding current because it's not holding anything, it's just powering the electronics. The only downside of this is that this is a 40 amp, and I believe it's only rated at 40 amps if you put it on a heatsink. And you can buy these kind of heat sinks which sit underneath with all fins going across, so I'll probably have to do that before I can put the full 40 amps through this. I think it also says in some of the eBay listings can be used up to 100 amps with forced air cooling. I think that would have to be quite a lot of forced air cooling, but allegedly you can use this just on the heatsink with passive cooling up to 40 amps. Let's take a look at the eBay listing. Okay, so here is the single phase solid state relay, DC to DC, which means DC control voltage, and you can put DC on the output. It even says that on the sticker. A lot of these are DC to AC. SSR 40DD, 40 amp, DC 3 to 32 volts on the input, DC 5 to 60 volts on the output. Now I bought this from China. It was £5.99, 83 pence shipping, and this one came from 365 bestseller. Right, scrolling down we can see some of the DA SSRs. So this one is a DC control voltage but AC on the output, and typically they're rated for mains. This one is 24 volt to 380 volts AC. But the DC ones tend to be 5 to 60 volts. DC, lower voltage, of course. Can't think of the reason for that. It's electronic. There's more current involved, maybe. No, because that's also 40 amp. Whatever. But further down, you can see the heat sinks that are available for these things. So here's a sort of heat sink which sits underneath the solid state relay. This one sits underneath it, but also to the side. It's a bigger affair. So I'm going to have to buy some of these heat sinks, try them out, see how well they work. What other information do we have on this SSR? None! And in the same vein as the 40 amp solid state relay, I also bought this. I mean, it's entirely different, but it kind of is designed to do the same job. This is a mechanical relay. This is 500 amps, so a good deal more than the solid state relay. So if I'm wanting to control very large currents, I'll probably have to go to a conventional coil-based magnetic. I think this has a plunger. It's almost a solenoid really. Relay, 500 amps on the contacts. They're pretty big. I've got a feeling they're M8. It'd be easier to take this out of the bag actually, wouldn't it? So let's do that. So these are 8mm ring terminals, which I used on the big batteries outside. Yes, they fit. So these are M8 threaded terminal posts, and there was probably a heavily sprung plunger in there. These are the terminal posts for the 24 volts, which is the coil. Of course, I chose the 24 volt relay because I'm using a 24 volt 8 cell lithium iron phosphate battery on my system. So might try that, probably end up using this simply because of its higher current rating. But probably what I'll do, I mean, I know it's not this, it's actually the other unit, which is the discharge controller, but it's got the same 30 amp Songle relay on it. So this relay will probably energize this relay, and then this will do the main current switching between those two posts. So this item on eBay I got from a UK seller located in Manchester, United Kingdom. It's a 4-pin, well, it's a 2-pin on the contactor side. I mean, is this a relay or is it a contactor? And is there actually any difference between those two things? 500 amp DC 24 volt is the coil voltage. It was £18.70, so more expensive than the solid state relay, but a lot more current. Free shipping. This came from Pondway in the UK. And finally, a little bonus item. Well, it's actually quite a big bonus item. It's so big it won't actually fit on my desk. There's an envelope there, and then under this foam top there are these little beauties. 4 prismatic lithium iron phosphate cells. Can I get them out from underneath the camera? Yes, just about. And those are these. They're Litokala 3.2 volt, 105 amp hour. That's the date. They're not bulging, they're absolutely flat, so they look pretty good. I'll put one on the desk actually and we'll have a proper look at it. So yes, this is it. 3.2 lithium iron phosphate, 105 amp hours. Now so you multiply the 3 volts by the amps and you get about 300, let's call it 330 watt hours. So of course 4 of these will be 1.3 kilowatt hours, won't it? Yes. So in this package we've got the metal work. It's basically strips and nuts to strap these 4 together. Now these have taken about 2 months to get to me because they can't be shipped airmail. So the seller, an eBay seller, put them on a boat and they were shipped to me by boat and then turned up via DPD, I think it was. And the seller was very good, very attentive, very communicative. I was taking a bit of a risk because, you know, buying big expensive things on eBay is always slightly risky, but I'm actually quite impressed with the seller. Now I'm not going to go to eBay because I've ordered 4 more of these and I'm going to wait until they arrive. That's going to be sometime in February, until I can be absolutely certain that the seller is completely kosher. Completely reliable, as it were. So this is just a sneak peek at what's going to become an 8-cell lithium iron phosphate prismatic battery pack. Yes, I was showing whether these things were bulging. Well, they're absolutely not bulging. I mean, they look brand new. They're all QR coded, and the date is very recent. Litokala is a known brand. They're very cold because they've been out in the shed and it's about 2 degrees. Oh, well, we saw that, didn't we, out there? But yes, I do think these are going to be really good for what I'm trying to do. But I do want to get the other 4 before I can be absolutely certain that these were a good buy. And of course, I haven't tested these, checked their capacity, that sort of thing yet either. Now, if you do want to know who the seller is, ask me in the comments, because I will give a link to the seller, but I don't want to promote that seller just yet. As I say, the seller appears very good. From the listing, it looks like the seller's based in India and just negotiating the transfer of these things from China to the United Kingdom. But he was very good, very attentive, very communicative. So if you want to know who the seller is, quite happy to answer that as a question in the comments. But yes, this is my little bonus. 4 of these beauties and 4 more on the way. And so these are today's Postbag items, with this representing the big prismatic cells there. So some thank yous. Thank you to my sponsor JLC PCB. Now I'm making some more printed circuit boards for my solar crypto system soon. Also a big thanks to my Patreons. I don't really thank my patrons enough, but they're hugely supportive of my channel, extremely generous people, been with me for years. So thank you, patrons. And I also want to say, oh, it's today. It's actually today, 21st of December. A very merry winter solstice to you. From this point in, of course, the days get longer and solar works better. Also, Merry Christmas! Happy New Year! Cheerio!